Okay, you guys, welcome to Chapter 9, Lesson 6. We're going to be doing word problems about wind and water current. So we're going to use system of equations, like we've been doing, to solve problems about speed and distance and time. So the first thing you need to remember is the equation distance equals rate times time. You're going to use that. Now, in all of these problems, we're going to have two different speeds happening. You're going to have the speed of some object, like a boat or a plane, and then the speed of the wind pushing against or with the plane, or the speed of the water pushing with or against the boat. Let's do an example so you know what I mean. Suppose that you can paddle a canoe. So you've got a little canoe, and you can paddle it at 3 miles an hour if it's in still water. So here's our canoe, and if you're just by yourself, you can paddle that thing at 3 miles an hour. But suppose you're not in still water. You're in a river, and the current is pushing you downstream. Downstream means the water is pushing you, and the water is adding 1 mile an hour worth of speed. So the question is, what's your total speed? 3 plus 1. So you're actually dealing with 4 miles an hour. Now suppose you forget something back at your camp, and then you've got to go this way, upstream. The water's still pushing this way at 1 mile an hour, and you are pushing this way at 3 miles an hour. Now what's your total speed? Your total speed now is 2 miles an hour. You go a lot slower because you have to fight the water's current. Here you get a free ride. Here you're earning every bit of inch you get. Okay, so now suppose that you take a trip and you, in the same canoe situation, you take 12 miles downstream, and then you have 12 miles back. Okay? Don't forget, the time of the trip is equal to distance divided by rate, because, remember, distance equals rate times time. So all we did was divide both sides by the rate. So time is equal to the distance divided by the rate. Now, suppose we just do this in a pond. You go 12 miles there, 12 miles back. Well, you're going to be doing 3 miles an hour for 4 hours to get 12 miles when you go down, and 3 miles an hour for 4 hours to get 12 miles to come back. But let's think about it. This is your still water moving. Now what happens if we throw in some current? Well, remember, if you go downstream, you're really doing 3 plus 1 miles an hour. And then the distance is 12, so if this is your rate and this is the distance, what's your time? Well, the time would be 3 hours, because 12 divided by 4 is 3. Now, this is where it gets crazier, right? What's 3 minus 1? On the upstream trip, you're going even slower. You got to do the 12 miles still, so 12 divided by 2 is 6 hours. You have to double the amount of time it takes to get back upstream. So your average speed here is 3 miles an hour, because distance divided by time is 4. 4 miles. Wait a minute. Excuse me. The total distance is 24 miles, and the total time is 9 hours. So your average speed is 2 2/3 miles per hour when you take into account your moving water, the river water. Okay, let's do another example. See if we can get this making sense to you. Okay, you can do the same thing with wind or with water. This next one will be with wind. A jet can travel the 6,800 kilometers distance between New York and Paris in 6 hours and 48 minutes with the wind. So 6 hours, 48 minutes, and that's with the wind helping. So we've got the plane speed plus the wind speed. Okay, now the return trip is against the wind. And so this time we're going to have R going this way. And it takes 8 hours. So the question is, how fast is the wind going, and how fast does the jet go? Okay, here's where we're going to introduce the two different variables for the speed of the jet and the speed of the wind. Now, we use the same basic idea. Rate times time equals distance. What's the rate of the plane with the wind? Well, it's going to be R plus W, rate with the wind, times the time. And we'll need to convert this into either all minutes or all hours. Why don't we do hours? So 6 and 48 sixtieths, which is 6.8. 6.8 hours equals 6,800 kilometers. Rate times time equals distance. Now, notice we have two variables, so we actually need to create another equation with the same two variables. Now, on this one, the rate is is the rate of the speed of the jet minus the wind. It's going slower. Rate minus the wind. And that one goes for 8 hours, and it takes the same 6,800 meters. Okay, so let's factor this stuff through. Or even better, let's divide both sides by 6.8 here, and what we'll get is R plus W equals 1,000. That's nice. And then divide this one by 8, and what we'll get is R minus W equals 850. Okay, now we have two equations and two variables. Let's go ahead and add them. 2R is equal to 1850, which makes R equal to 925. So we know that R is the speed of the jet, kilometers per hour. Then all we need to do is plug it back up into here, and we get that the wind speed, 925 plus W equals 1,000. So W has to equal 75 kilometers per hour. The original problem asked, given the 6,800 kilometer distance between New York and Paris and the time there and the time back, what's the speed of the jet? Well, we found out the speed of the jet is 925 kilometers per hour, and the speed of the wind is 75 kilometers per hour. Okay, go ahead and try some and let me know if you have any questions.